Alright guys, for the next two, I'm just actually going to do 15 and 19. We're skipping all the ones that have parametrics in them. Okay, so for 15, we have the same problem we had for 14. We've got a variable raised to a variable power, and we can't have that, so we need to take the log of both sides to start logarithmic differentiation. When I do that, we get to rewrite the equation like natural log of y equals, we can bring this power down in front, sine of x times natural log of x plus 1. Alright, now we're ready to take the derivative implicitly. Derivative of natural log of y is 1 over y. We just took the derivative of y, so we should write that. Equals, now we have a product rule. So the derivative of sine of x in this, derivative, we have u, sine of x, times the derivative of natural log of x plus 1, which is u prime, or 1, over u, plus natural log of x plus 1 times the derivative of sine, which is the cosine of x. To clean up our answer, we're going to want to multiply both sides through by y. And I'm going to write this as sine of x over x plus 1 plus cosine of x ln of x plus 1. The order there doesn't really matter. And the whole thing we're going to multiply by that original statement, which was x plus 1 to the sine of x power. Alright. I'm going to leave this thing as my answer. Alright, number 19. I think the difference here is they want you to take the second derivative. So we've got lots of room here. We need to do it implicitly because there's no explicit y equation. We've got 2x, we just took the derivative of x, minus 2y dy dx equals 0. Solve for dy dx by subtracting the 2x, dividing both sides by the negative 2y, and we get an expression that dy dx is equal to x over y. At this point, we want an expression for d squared y, so we're going to switch gears here and take the derivative again. The derivative of dy dx is d squared y over dx squared. That means the second derivative. We need to use a quotient rule. So we've got low times the derivative of x, which is 1 dx dx, minus x times the derivative of y, which is 1 dy dx, over y squared. Alright, we can't leave dy dx in our answer, but we do know what it equals. It equals x over y. So we can rewrite this as y minus x times x over y, so it will actually be x squared over y, all over y squared. We're never going to leave our fraction in a fraction, so we need to combine them. In order to combine them, they have to have the common denominator. In that case, this case, it's y. So that's how we can change this. They both have a y. This gives us the expression y squared minus x squared over y, but we're dividing it by y squared, or in this case, multiplying it by 1 over y squared. Same thing. Put it all together. Y squared minus x squared over y cubed.